So, Paul, this definitely doesn't look like a cabin in the woods. What's going on here?
That is our DTEC series, a COVID extraction and CLIA laboratory made in a shipping container. The team was tasked with a mission of finding small spaces to deploy extraction and testing units so that hard-to-reach people, poor people, can get the same tests and test results as everybody else. And one of the beautiful things is that we build it remotely off-site, and then all of a sudden it can be delivered and activated in days, unlike traditional construction where, it'll take years.
Hey Chris, how on earth does one go about transforming a container into a lab?
I think when you begin your cutting and welding on the box and you start mating them together, it's just ensuring a tight seal so that you can take one box and add 3, 4, 5, however many you want, and make it feel like it's still a single structure.
Guys, this seems like such a Grimshaw project.
From the outset, we've used industrial design and integrated it into architecture. So you can really look at how you design a building as a kit of parts.
Let's get to brass tacks. How does this literally work?
There's a collection stage and then there's the actual laboratory stage. So samples literally come in one door and come out the other door.
So when we first designed it, it was a 3-hour process with a 2-hour test, and there's now a 90-minute process with a 45-minute test, and the next one coming up actually tests for influenza and COVID-19 at the same time.
It's a very complex process and it looks very simple.
And that's the art, is making something that's complicated look really simple.
Well, this is a typical laboratory for you, where we analyze the blood. So let's pretend this was a specimen that came in from someone complaining of chest pain. Our goal is to make sure that we test this in the shortest period of time so that we can get those results back to the physician as soon as possible. So this is the Atellica Solution from Siemens Healthineers. This analyzes blood glucose, in addition to testing things such as HIV, pregnancy, cardiac conditions.
Wow, this machine does everything.
So we're going to load it onto the system, and we do so in a priority or stat rack. A robotic arm will pick up the stat, so that's prioritized over all of the other routine samples that are on here.
So Scott, I can see how these things are completely modular. Look at how they all fit together.
Exactly. We can connect these together in over 300 different configurations, just like Legos. We did that so we can fit into any size lab and scale the system to fit customers' needs. And it's future-proof. We're adding new functions all the time. For example, one of our most recent additions is a decapper.
Oh, wow. Where was that on Super Bowl Sunday when I needed it?
This is our new tablet application we just launched.
Looks really clean. It looks really, can I touch?
Yeah, definitely.
Now, I know nothing about diagnostics, but I feel like I could use this straight out of the gate.
We try to make tasks as simple as possible so it doesn't take a lot of training to use the system.
I think you did a great job.
Sabrina, how many of the buildings out there your company owns and manages?
I can't even count. We build them, we buy them.
It's quite a responsibility, huh?
So we make a point of staying ahead of that leading edge in technology, whether it be to deliver an elevated architectural experience or the latest technology. In this building, we installed a digital twin. So a digital twin is a virtual replica of the building systems, whether it be security, HVAC, your metering. All of these are synthesized onto one screen, which allows a building manager or operator to better operate their building and provide comfort for our tenants. And we can foresee when a piece of equipment is going to fail. And in addition, the digital twin will tell us whether or not that piece of equipment is under warranty and what is the phone number we need to call to have that piece of equipment changed.
So we own just under 2,000 buildings globally.
Wow.
So the opportunity is enormous. And if we get the technology right here where we can decrease energy consumption by 25 or 30%, then we'll be able to take that and deploy it to our other buildings.
So Ian, show me how it works.
Sure. This is the digital twin of One Manhattan West.
I see there are a couple of red lines. What does it mean?
It means there's a piece of equipment that's in an alarm state. We call those insights. And we could turn on additional systems like the mechanical system, which is all the ductwork and the equipment like the fans. And we can access very technical data so that if it's your responsibility to go out to that piece of equipment, you have all the information that you need to make an informed decision.
So the goal with Fresco is to get this beautiful analog quality into a digital environment. So this is Fresco. Let me show you our digital oil paints. So you'll see when I'm painting here, we've already got that kind of 3D streaky texture in here. And then when we bring in extra color, I get that same gorgeous blending, smudging effect. So with watercolor, you know, the amount of water on your brush affects the paint effect you get. And then there's also blending effects you get when you mix colors. So we've, again, tried to take the best of both worlds of this into Fresco, and I can blend another color into it and look at how those blend together.
It keeps blending after you've taken the stylus off the screen, just like real watercolor would.
And actually, Fresco is now available also on the iPhone, so the rectangle gets even smaller. So now I'm actually painting with watercolor using my finger right on my phone. But there's one more thing I want to bring up, and that's a collaboration feature. Kyle and I are working on something together right now.
Hey, Kyle.
Hey, Kyle. Hey, Will. One more thing I think we should definitely do, Kyle, is add some visible magic kind of sparkles coming out of the hands and the wand. And now we've got stars. Yeah, just like that.
Cool.
Charcoal is something I use all the time, and using it here feels exactly like the real thing. If I want to do a live stream, I just tell everybody, hey guys, I'm going live, and right from inside the app, I start broadcasting, and they can comment and chat and ask me questions while I'm drawing. Okay, check it out and tell me what you think.
Oh man, that is so awesome. My beard has never looked better, and it looks like a real sketch from a real sketchbook.
So David, you are a compost guy, is that right?
No, actually, I'm an architect and designer. We created a new building product that starts just with earth like this. Take, for example, corn. Take all the waste from growing corn and make a building product out of it. So this is some chopped up corn stover, and you can take this material, combine it with microscopic bits of mycelium, which is the root-like structure of mushrooms.
Okay.
And then in about 5 days, it grows into a solid object with no added energy. We've created a new kind of architectural brick. Basically a new low-carbon building material. It has very low environmental footprint. And even though it's lightweight, you can make a pretty strong and big structure out of it. This is a scale model of the structure that we built. It was 40 feet tall in real life.
Wow.
And this was in the courtyard of MoMA PS1 for 3 months of the summer. Then at the end of the summer, it was a temporary installation, so we had to take it down. We took the bricks, we brought them to this compost site here, crumbled them up into smaller pieces, and then after a couple of months, they returned to soil, which we could start the cycle again with. We could plant new crops and then have a new cycle of life.
So Justin, these bricks came here to you and you started breaking them down, right?
Yeah, that's what's amazing about these bricks is that they're actually compostable and they can be just broken apart.
The big idea here is that this is part of a whole cycle, right?
Yeah, like sort of mimicking a complete ecological system.
This is a building material that's non-toxic enough that I would even let my own son take a bite of it.
How's it taste, Saul?
Like oatmeal.
We really need to find new techniques and new materials to go easier on the planet. Now this mushroom brick may be part of the solution. I'm just not sure that I'm ready to eat it.
We did the design in the New York studio, and we had a very ambitious program from the outset. And that was to create something completely self-sustaining, generating all of its own power, cooling, generate all of its own water. So this is the original concept model. So what you're seeing is that all of the exhibition space is actually sunk below the ground, and then we take the landscape up over the rest of the building. So then after that, how do you provide all the energy to meet all of those needs? Well, obviously, to put solar panels on the roof. And this is 130 meters across this way. But when we did a calculation, we realized it still wasn't creating enough power. So we had a problem. We thought, well, maybe it's a landscape piece, something like a tree.
We found this dragon tree that was very prominent, and it met some of the architectural attributes we required for this energy tree, and importantly, it would create a lot of shade. What we needed to achieve is something that was strong enough to support a fairly lightweight disc up above. There was a company only 10 minutes from the site called Premier Composite Technologies that builds with composites and carbon fiber. It was a perfect match because they also worked with a photovoltaic company, Sunovation, and they could help us develop this lightweight disc at the top. It tracks the sun from morning through to evening around a vertical axis, and overnight it returns back to its beginning position for the next day.
So far, this enormous innovation appears as a one-off, but there's already talk of making this reproducible. We could be looking at a whole new way of building renewable, off-the-grid, large-scale structures.